In this video, we'll be looking at the normal distribution. The normal distribution, shown on the screen, has most of its data centered around the mean. As we move away from the mean in either direction, scores become less likely. We can see that it does that in a symmetric way on both sides of the mean. The normal curve goes from negative infinity to positive infinity, and the area under the normal curve is 1. Now these numbers under the normal curve along our x-axis, these are called z-scores. And they tell us both how far away from the mean a score is, as well as in what direction. So for example, -1, the negative tells us that it's below the mean, and the 1 tells us that it's exactly 1 standard deviation away from the mean. The distribution that we're looking at here is called the standard normal distribution. And the standard normal distribution has a mean of 0 and a standard deviation of 1. So if you're working a problem and it doesn't give you a mean and a standard deviation, chances are you're working with the standard normal distribution and your mean is 0 and standard deviation is 1. So what we can do with this distribution in our calculator is to find the likelihood that a score falls within some area. So for example, we could find that the likelihood that a score falls between -1 and 1, or in other words, within 1 standard deviation of the mean. And so what we're going to find is this red area right here. And we'll find that by using the normal CDF function on our calculator. So to get to the normal CDF, you'll push the second key and then the vars button, 3 buttons up from the 9 key on your calculator. We want to go down to normal CDF. The CDF stands for cumulative density function. Now some of you may get this menu option here. If you have an older calculator, you'll just get what I have written on the screen here, normal CDF with a parenthesis. So I'll write it out on the screen as well for both types of calculators. So what we're going to put into the normal CDF is the lower number, which is the smaller of the numbers, the upper number, the mean, and the standard deviation. So if we're going from -1 to 1, our lower number would be -1, our upper number would be 1, and then since we're using the standard normal distribution, we have a mean of 0 and a standard deviation of 1. So we'll put those same numbers into the calculator. So -1 as our lower, 1 as our upper, mean of 0, standard deviation of 1. And again, if you don't have that menu option, what your calculator should look like is what I've got on the screen right there. And so what we end up with is about 0.6827 if we round to 4 decimal places, which we could also say is 68.27%. Since the area is 1, we can also represent this as a percentage very easily. So this is the standard normal distribution, mean of 0, standard deviation of 1. We'll also see some problems where we have different means and standard deviations. So for example, if a sample of people was measured and the average height was found to be 67 inches with a standard deviation of 3 inches, we could find what percentage of the population we would expect to be taller than 72 inches. Now of course we'll have to assume that it was a good sample, but if we can assume that, then we can find this percentage. So let's first draw our distribution. So we have a mean of 67, so that'll be right in the middle. And then we want to find the percentage of the population taller than 72 inches. So that'll be above the mean, and so what we'll be finding is this area right there. So again, we'll use our normal CDF function on our calculator. And so again, what we want to put in there is the lower number, the upper number, the mean, and the standard deviation. So we can see that the lower number would be 72. That's the smallest number on that area that we're trying to find. But the upper number, we'll notice we don't actually have one. We're actually just going all the way to infinity. Now, of course, it's impossible for someone to be infinity inches tall, but since the normal distribution does go from negative infinity to positive infinity, we will want to put infinity here, or in our case, something fairly close to infinity, so that we can find our answer. So what we're going to use is 1e99, which is just a really large number. So that's 1 with 99 zeros after it. And that'll be close enough to infinity for our purposes. So, how do we put that in the calculator? Well, let's go back to normalcdf. So our lower here is going to be 72. Our upper, we want to put 1e99, so we'll do 1. The E button is right above the 7 key on your calculator. We'll push 7, our second, and then the comma button right above that 7, and so that's how we get that E, and then 99. And so if we were, for example, trying to find the percentage of the population shorter than 72 inches, we'd be going from negative infinity to 72. So there we'd use negative 1e99, comma 72. All right, our mean on this problem is 67 inches, and our standard deviation is 3 inches. So mean of 67, standard deviation of 3. And what we end up with is that the area would be 0.0478 if we rounded to 4 decimal places. The question asked for it in percentage form, so that would be 4.78%. So we'd expect 4.78% of the population to be taller than 72 inches.